So when you talk about general function idea, now, firstly, how do you know a given graph or a relation is a function? So one of the basic background knowledge that is expected to know is the something called as vertical line test. So if I give a graph and the vertical line that you draw cuts the graph at more than a point, then that relation is not a function. So now, for example, here, if I draw the vertical line here, this is called vertical line test. And now here it cuts at only one point. Now that means that the graph or the function is given relation is a function. Now, when you look at function as a key concept, obviously we all understand that domain is the input. So this is like a function here. You input domain and your output is the range. So this is your range. Now, graphically and logically, they both should be achievable. Like when you're doing the domain of a function, graphically you should be able to see it. How does it look like? Because most of the domain and range questions that you will see will be in paper 4 for international math. So when you look at a simple graph, now for example here, let's say I'm just showing a simple straight line graph. Now if I wanted to find out the domain for this function, now as we can clearly see that my domain is the x values for which a function is defined. And now you can clearly see that if I look at the domain, these x values have been taken. So you can see the graph exists between these two the x values. So now let us say if this x value is -1 and this is, let's say, +5, my domain is going to be x between -1 to +5. That's your domain. Now, when you look at the range is basically from here, that's your this y value. When you look at the range, you look at always the y value. So along y-axis, if you see, what's your y values that are covered? Now let us say these y values are, now let's say this value is, for example, 2, and this is, let's say, -3. So this coordinate was actually -1 comma -3, and this is, let's say, 5 comma 2. So when you look at the range in this case, the range in this case will be y between -3 to 2. So this is the range of this particular function. Now let's take another example where you have some little different type of question, that is maybe rational functions or quadratic functions. So how do we predict the range for that? Now lots of times what happens is that, let's say, you're given a function like a quadratic function, x squared plus, let's say, x or something, or x squared plus 2x. Now, when you sketch this quadratic, you're going to get a graph something like this, which is a happy face graph on your calculator generally. So this is cutting at 0, -2, and there'll be a line of symmetry here at -1, and you'll have some minimum value which you can calculate from calculator, or because since you got this coordinate as -1, because it's right in the middle of 0, -2, you can plug in this equation to get the y coordinate of vertex. So in this case, it is going to be -1 the whole square plus 2 times -1, which is 1 minus 2, which is -1. So in this case, the y value is -1, minimum y value. Now, if you look at the previous question, in previous question, the domain was actually restricted for the given equation. But out here, it has not been restricted. And I can see that x can take all the real numbers. So there is no break in the graph, or there is nothing where the function is not defined. So here x is basically all real numbers. But if you look at the range, the y values are actually just above -1. So y values are just above -1. So when you look at the range, you say y is greater than or equals to -1. So this is your range for this function. Now, one of the most interesting questions that comes in the paper 4 is to predict the range for a restricted domain using technology. So I'm just going to touch base upon that once I explain logical way of doing it. Let us see how do we first do logically that kind of question. So now I'm just showing it to you, one of the example that has been probably asked in an exam. So the question is basically, question is y equals to 3x minus 2 over x minus 5. Now, ideally, when you look at this function is a rational function. When you sketch the graph of this, it is only there will be one point where you won't have the x coordinate defined and x value defined, and there will be one point where y will not be defined. Now, where it is not defined, when you look at x belongs to real numbers, if I take x value as 5, now for example, if I input x as 5, my y value will be undefined. Now, when you look at the range, now if you look at your graph and try to sketch it, the graph on a calculator, if you see here, it is going to be something like at x equals to 5, there is a vertical asymptote. At x equals y equals to 3, you will notice that there is a horizontal asymptote. Just to touch base upon the concept of vertical and horizontal asymptote. Now, for vertical asymptote, you equate denominator to 0. So let's say x equals to 5. That becomes my vertical asymptote. For horizontal asymptote, now either you can look at the graph, because in International Math Paper 4, you will have your the technology with you. So you can make the V window for X value really large, and you'll see that the graph almost becomes stagnant around that point. So now when you look at the horizontal asymptote here, it is y equals to 3. So y equals to 3 is your horizontal asymptote. And how do we obtain it? In short is like a shortcut is, if you have ax plus b over cx plus d type of equation, a linear over linear or a quadratic over quadratic, in that case, you just take the coefficient of leading term, which is like coefficient of x. Here it'll be a over c, that is horizontal asymptote. So that's what I took exactly here. Y equals to 3 over 1, that's your horizontal asymptote. Now, when I sketch the graph of this, approximately at 2/3 is the root here. So at 2/3 is the root here, and y-intercept is at 2/5. So you can find that out by plugging x as 0 and y as 0 respectively. For y-intercept, you plug x as 0 and you see what's your y value. So if I plug x as 0, you get 2/5. So here it will be something like this. If you actually have calculator, you don't need to worry about these critical things. Now, in this case, if you look at the domain is all real numbers apart from 5. Now, what I would advise is a couple of things is that when you draw the graph, there are a couple of mistakes that we do that I'll just tell you once you're using technology. So x belongs to, let's say, real numbers, and x should not be 5 is the domain. And range is y belongs to real numbers, y should not be equals to 3. So that's your range and domain for this particular question. Now, the problem is in the exam, what they will assess is not for this natural domain. They might ask is just find out this range of this function between -3 to, let's say, +10. So let's say in this case, how do we tackle the situation? So our objective is that to actually understand now how to do this entire domain and range concept purely using GDC. So now what I'm going to do is I'm going to basically show how to do the same calculations on calculator, because lots of times you tend to not think about that you have a calculator and you go on manual approach for paper 4. So now let us say first thing is that now I wanted to plot and see how is the behavior of this function. Now let's say I'm going to go into the graph function. Graph, there are two graphs. One you see is dynamic graph, and also there is conic graph. So we always use the plain graph feature. And here when you enter, you will have to basically feed your function that you have taken. Now I'm just cleaning this part. Let us say in this function, my equation is 3x minus 2 over x minus 5. So when you look at this is 3x minus 2, so 3x minus 2 over x minus 5. So when you look at this part, you just type it out. Now make sure that your type of the graph is, now when you click on the type, sometimes you'll see x equals to or r equals to and all. In that case, your graph will not come proper. So you just say the type and make sure that you select always y equals to graph. So you select y equals to and make sure that your type is correct. Now, when you go into the, when you sketch the graph after that, you can see the graph sometimes is not actually oriented in the entire plane. So most of the times you will see that there is a grid given on your international math paper itself. So which will already have a scale. Now when you look at the scale, like for example, if my graph already they say, okay, draw on this paper, you draw the graph. Let's say from -3 to let's say +3, you draw the graph. So it means that in that case, you keep the window for x between -3 to 3. Sometimes it'll be, let's say, -20 to +20, let's say whatever they have given, the grid values. And similarly, you'll have range for y values. So instead of just randomly putting the values, you can just use these values as a guiding to adjust the view window. Now, right now, I'm showing all the possible ways to see your graph. Now, when you look at here, what you see is that this is your basic graph. Somehow, I can change view window, go to view window, and you can make it standard if you want between -10 to 10 x values and y value also between -10 to 10. Now, when you're doing this, you get basically this as a graph. Now, this doesn't look like correct graph to me. So what I do is I use the window that has been given, for example, on my paper. So I just go here, I change the x minimum at -20 and x maximum at 20. And let's say other y values are not changing. So my graph is something looking something like this. Now, unfortunate part is the students, when they do, they draw the graph in their grade on their paper as this. So the graph that they draw is something like this. Now, it will not get full marks. What happens is, because it is, number one is you're forgetting some of the critical feature, that it is a rational function where you haven't drawn a vertical asymptote. So you make sure to it that you draw a vertical asymptote. So here your vertical asymptote is something that the graph is not showing. Sometimes when you press zoom and press auto, you can see that there is a vertical asymptote around at that point. But at that point, your graph is completely changed with the scales. If I press F2 and F5, F2, F5, if you do, you can see your graph wherever it is into a concise window. So you can use this feature as well, zoom in, zoom out. So F2 is the zoom feature. So you can use to get the graph. But you can see that there is a vertical asymptote here. So that vertical asymptote, if you don't draw, you get automatically 1 or 2 points down. Second point, now horizontal asymptote. Now how do I calculate horizontal asymptote using my calculator directly? Now there is no as such way to get the horizontal asymptote, because not like it's not allowed in IB exams or international math exams where to have horizontal asymptote directly. So in this case, you have to use your common sense that horizontal asymptote, I'm going to just make the view window really large. So when I make view window really large, let's say I keep it to standard first. And now if I make view window really large, let's say from minus 1000, let's say from minus 1000, let's say to minus 10,000 to plus 10,000. That's your X view window. And you'll notice that the graph has almost become stagnant. So what I just do is I trace the value at, let's say, maybe 500 or something. And you'll notice that the Y value is coming close to 3 or something, or maybe just now go to 100, 1000 here. You'll notice that the Y value is close to 3 now. So as you go on, the Y value becomes stagnant around 3. And that's the indicator, that's your horizontal asymptote. So when you're actually looking at these features, you need to show that also on your graph. Without showing that, you can't actually like get the full points. So this is just for natural domain. When you're showing for natural domain, make sure to show the arrows at the ends, because that is they're also important. Graph should be very clean, neat, tidy with the roots and all mentioned. Now, how do I find out the roots of the graph? So I'm just reducing back to standard form. So when I find out the roots, this G-solve feature, which is F5 button, if you press it, you're going to get roots. You can just find out where does the graph cut x-axis. G-solve max. There is no maximum because there is no turning point here. Then you have G-solve min. Lots of times, actually, students don't know how to find out the turning point or minimum point or a maximum point. So turning point is nothing but it is like minimum or maximum. So this is like basically like entire key concept that is linked up with your functions and technology, that you don't need to do manually the working for maximum and minimum. You just on your calculator, you type out, let's say for example, if I have a function, if I make it like a function something here, I take another function which is x squared, I would be able to see the maximum or minimum for the second graph. If I press gsolve and there's, you can see there is a minimum point, you can find out by just pressing gsolve min. You can see x is 0, y is 0. So these are some of the features that you have to use. Without that, you'll not be able to do the questions correctly. Now, as far as finding the vertical asymptotes are concerned, don't rely on technology. Just use your common sense. Your denominator must be 0. Now, for example, all of these graphs, I could just straight away do equate denominator to 0. Now, for example, here, I would say x squared plus 3x plus 2 equals to 0. Solve for x is -1, x is -2 by factoring, and you get the vertical asymptotes. Here, if I equate denominator to 0, I get x is 0. Here, there are 3 vertical asymptotes. So x is 1, x is 2, and x is 3 straight away. So only the denominator, if I equate to 0, I get my vertical asymptote straight away in the question. And in international math, there has been the questions where the order of the vertical asymptote has gone up to 3 or 4. So you have to have this kind of understanding of how to use both concise use of technology and uh, the general way of like interpreting a rational function. Now I'll just show for the fourth question, how do you find out the horizontal asymptote once again, so that we are clear with this. Now generally what happens is that if you have a rational function, and if you see that if your numerator has lower degree equation than denominator, your y equals to 0 is always the horizontal asymptote. Now what I mean is, for example, if you have, let's say in this case, you have 2x minus 3 is a linear equation, and this one is a quadratic equation. Now 2x minus 3 is a linear which is lower degree compared to quadratic, so automatically in that case y equals to 0 you'll see is the horizontal asymptote. But in case of your technology, it's always good to verify. So what I'm going to do is I'm going to just show the second graph, which I have plotted now, uh, which is, let us say, I'll just delete this part. I'll keep it here. I'll not delete it. I'd love to use it later. I can delete this one. And let's see now. My second equation that I've got is, let's say, 2x minus 3 over x squared plus 3x. So x squared plus 3x plus 2. So this is my second function. I mean, I'm just going to deselect this one. So now I can see the red graph that you see is your function that you have. Now, in this case, you can see that there is only 2x minus 3 over x squared plus 3x plus 2. There is one vertical asymptote somewhere here. And you can see that there's something which is not, doesn't look like right. Now, if you scroll up and down, you can see maybe if I make the view window standard, you can just see if there's any graph up, because yeah, you can see that there is a turning point graph up also. So it is really important that you first like zoom auto, in case if you can't see a graph at all, you can see when you see zoom auto, you can see the vertical asymptotes also, you can see the turning points also. So this is a interesting feature that I advise to my students, is like use zoom auto to, in case if you can't see entire graph. Now you notice that as I said that your x-axis is the horizontal asymptote, you can see evidence here as well, that as I'm going for the larger x values, my y values are already becoming 0. So how do I interpret these stuff is basically by some combination of my personal knowledge, which I got. There are two vertical asymptote. You can see one is here, other is here. And second is horizontal asymptote of y equals to 0. And now other things you can find out using the calculator, right? Like for example, vertical, the roots, y-intercept, and then copy down the shape. And while you're copying down the shape, if you copy like at this stage, you'll not be able to see the entire graph. So in that case, whatever the window that they have given, follow that and make the as accurate graph as possible with the vertical, horizontal asymptotes clearly, along with the turning points. Now, how do I find out a turning point in this case? Let's see if there is a turning point. I'm just going to clear out these values here. So let's see if there is any turning point. Now, when I press gsolve max, if I find out, you can see that there is a turning point here. So it means the graph has gone up. It is somewhere around 0.15. So the graph that has gone up, there's a turning point, and then it is becoming asymptote. So it's like this. So somehow the graph is like it has gone up after this point, and it has like turning point, and then this becomes. So you need to show all these critical features in the on the like your paper, otherwise you'll not get the full points. This is very, very important points I'm talking about. So please be mindful of these stuff which is related to sketching, because sketching will be for around 4 to 5 marks. It'll take some questions for practice, but at least this is what I would expect, that make sure to it that you copy, use technology to the most efficient format. So now the main challenging concept that we face is logical way of representing the domain and range, or like graphing for the restricted domain. So now, for example, if my function is 3x minus 2 or x minus 5, and now I have been asked to draw this graph from, let's say, minus 5 to, let's say, around 7. Now, this is the domain that I have been given, and your graph only should be between these points. Now, up till IB, like I've been teaching higher level kids, and we see that even in higher level, they don't have this knowledge to basically how to actually do this on technology directly, because they'll just now go on to view window and make the view window, like for example, this is my graph, and I'm just going to delete the second one because I won't need it. Now, let's say this is the graph, and here what we do is, let's say if my function is, put a comma, and then you put shift and put the square bracket. If you see square brackets on this plus and minus sign, so open, if you press minus, it closes. Now, in this case, what is interesting is that, let's say minus 5 to 7, if I type, minus 5 to 7, it automatically cuts the rest of the graph and just retains what I want. So this is the good thing about this, is that it cuts the rest of the graph. Now, if I make the view window standard also, you will see that the rest of the graph will not come. Only this domain graph will come. Now, even if I shift the graph and all, here you can see the actual shape. Now, at this point, what I would like to do is, I would like to find out these endpoints. Now, if I trace the value, now, when you're graphing, I would say that, okay, now vertical asymptote is at 5. So how are you going to show this graph? So x equals to 5 is vertical asymptote because it comes into that domain that they have specified. So you're going to do that. Number 2 is the horizontal asymptote is at y equals to 3. Y equals to 3, you're going to write down because that might be a follow-up question. After that, what you have is, you cannot draw that natural graph that we had drawn, because like lots of times students just draw like this and they leave it, and what they get is actually close to 0 marks. Now, what we do is, actually in this case is, we have to be mindful that the domain is only from minus 5. Now this is minus 5. Okay, this goes to infinity, so I'll let it go. But here again, there is a 7. So your graph must end here at 7. And this goes to like becomes like a vertical asymptote here. So that goes to infinity. But now the interesting point is that you can see that also from your graph. Now, if you just copy from your graph, you might copy just a random 2 parts. And if you don't show these vertical, horizontal asymptotes, you will not be able to show an accurate graph. And say accurate means it has to be with all the most possible information that you have. Now, in case if I wanted to find out that, okay, what is this endpoint? Now, there are 2 marks awarded for endpoints. If there are 2 endpoints, 1 point marks for this and 1 marks for this. So if I don't give this coordinate of this endpoint, you'll get straight away 2 marks minus out of 4 marks. So you've drawn everything, but because just like you're not putting the endpoints because you didn't know how to do it, it can cost you marks. Now, one thing you can do is, because it doesn't take much time, you can either plug x as minus 5 here and find out the corresponding y value, plug x as 7 here and find out the corresponding y value, or you can just use a calculator. Now, to use calculator, you just press the trace function, use the trace function. Just type trace button. If your calculator doesn't show any of the numbers, it means it is not on trace. Just press F1. Now you can see these numbers. Don't worry about this dy by dx. You'll understand that in later part in AdMath or IB. But right now, if I trace at, let's say, just minus 5, just type minus 5 at your screen and say execute. It will give you the value of y. So value of y is 1.7. So value of y is 1.7. So this value, this coordinate when you write is negative 5 comma negative 1.7. This needs to come. Now similarly, if I trace at 7, don't have to type anything. Just don't have to do any different stuff when your trace is on. just type 7. At x equals to 7, you can see the y value is coming as 9.5. So this y value is 9.5. So 7 comma 9.5. Now, what happens is that because if you don't get this answer, next answer for 3 marks will be absolutely incorrect. Now, what is a 3-mark question? Now, 3-mark question is something that you've already done, is find out the range. Now, why it is so much expected, why I'm emphasizing on this part is because when I look at the range here, it is not now y belongs to real number, y should not be free. Now, range has completely changed because the function's domain is now restricted. Now, when I look at the range, guys, when I look at the coverage of the y values, whatever my y values the function takes, now you can clearly see that the function takes any value below 1.7 and any value above 9.5. Any value below 1.7 and any value above 9.5. So when you find out the range, I write on the range of this function is going to be y greater than 9.5 or equals to 9.5 and or y less than or equals to 1.7. So this coordinate that you see is now one of the decider for your answer as well. That's why this becomes one of the very, very important skill for you to have during the examination of the functions. Now, let us say on the similar graph, on the same graph, they will ask us, now sketch another line, which is 2x plus 3y equals to 5. Now, let's say that's another equation that they have given. It might be in standard form or it might be in y equals to mx plus c form. So I'm to plot on the graph on calculator, it won't directly plot this graph. So you got to plot y equals to 5 minus 2x over 3. So this becomes 5 over 3 minus 2/3 x. So this is your, or you could just use this graph, that's okay. So in order to get proper y equals to mx plus c format, you can use that. Now they'll say plot the same thing on the graph here. So when I do that, okay, I would like to just, let's say, make the windows more clearer. I would like to see the y values. Let's say I put y value maximum to 50 so that I can see my at least part of the graph, how it looks like. Okay, now on the same graph, if I plot now y equals to 5 minus 2x over 3. So let's say 5, use fraction, you can directly put this. So 5 minus 2x over 3 if you have. So this is my graph that it looks like. Now, here it is, let's say, I don't think so it is cutting GSOL. If I do intersect, it is not cutting at any point. So I would just change the equation a little bit. Now, instead of here, let's say, I would just make it minus here. So minus here, and it becomes plus and plus. So my equation, let's say I've given that. So this will be given to you. You don't need to change. I'm trying to create a question. So I'm just making the changes accordingly. So here will be 5 plus, let's say 2x. Now if I plot 5 plus 2x over 3, how does my graph look like? So this is the graph on your screen. Now, when I want to, let's say, solve for the equation, now they will say use your equation. Now there are multiple times they'll ask. Okay, number one is, suppose this function is represented as g of x. Okay, this function is g of x. This is my given function. I'm just going to erase out what has been given here. So let's say this is my function g of x. And now they will ask us to do following stuff. Number one, solve where g of x is 0. Or for that matter of fact, f of x equals to 0. In that case, you don't need to do anything apart from just finding the roots. Now, when you say g of x is 0, it means that asking you to find out that x coordinate where your y value is 0. Find out the x coordinate where your y is 0. Find out for both the functions, let's say. Let us see how do we get that. Now, if you have two graphs plotted on your screen, you can find out the roots together, but you have to select the functions one by one. Now, let us see. When I find out the roots, if I press GSOL is the main button here. Now, when I find out the GSOL roots, it'll ask me which function do you want to find out the root for. If you want to find out for the one which is blinking, you can just say execute, which is going to give you the answer. So the answer where f of x is 0 is actually, you didn't do anything, just you write x is 0.666, or which you can say 2/3. And obviously, If I equate this to 0 and solve for x, you'll see that x is 2/3 as answer also. So that's your one shortcut which is there. Now let us say I wanted to find out the roots for the second function, like gsolve and let's say roots. It will again blink and you'll say, okay, which function? So you can select, okay, I want to pick up the red one. So you can just use this big button and still put upper, like, just this button or this one or this one. It will take the cursor to the other function. So now let's say I want to find out the roots for this. Just execute that. So you can see that it cuts at -2.5 and that's your answer. Now, the question is that they will ask us to solve for the equation, use your graphs to solve for f of x equals to g of x. That is, they can give it to us. So how do I solve these two equations? In that case, they're asking, actually, if you look at reasoning wise, for what x value is your y value the same for both the functions? That's what is the context. And that happens when the two functions intersect. So wherever the functions intersect, you have the same x coordinate and same y coordinate. So you, in that case, what you just got to do is just do gsolve, and intersect. And my correct answer for this will be not the y coordinate. Answer for this question is going to be just the x coordinate, which is x is -1.16. Sometimes you'll have more than one solution. Sometimes you'll have more than one solution as well. So that part you'll have to be careful about. Now, so this is something which is f of x equals to g of x, or sometimes they'll ask you, okay, solve where f of x equals to 2, or let's say where f of x equals to, let's say, 8, or where is f of x equals to 20. So what I'm going to do is, like, I'm going to just draw the second line as y equals to 20. So here I'm not going to draw, okay, I'm not going to erase this. So this part, let it be here, but I'm just going to take it y equals to 20. So my function is y equals to 20. And in that case, again, you find a gsolve intersect. So that answer for it will be 5.76. And of course, I'm not ruling out the manual working. One of the reasons that the students are not able to complete paper 4s or paper like which are with GDC basis, that they forget that they're GDC. So what I'm trying to say is that these are the quick techniques to solve the equations without much of the hurdle. Otherwise, you would have to do equals to 2 here, 20 here, and then you solve for x, which is like cross multiplying, wasting time. So you have to save your time. In case if it's just a mark or two, just use this. Otherwise, anyway, you have to show the work. So coming back to the previous equation that we were doing, now I'll just deselect this one, and I'll say that, let's say, I'll deselect this one. I'll select my second function now. Okay, now my question here is basically coming back to the inequality. Now, when I solve an inequality, now these are some of the very critical questions and decider for A star. Now, these are the questions that most of the people find challenging, and you need to have that open-mindedness for this. And the question here is that use your graph to say where is this inequality holding true, f of x more than g of x. In simple terms, they are asking you solve the inequality where is your f of x higher than g of x. Now when you say f of x higher than g of x, what does it mean is that, look, f of x graph I drew is basically the purple one, and g of x is the red graph. So I wanted this f of x graph to be above the g of x graph. Now that's how I would solve the inequality graphically looking at the function. Now, for what x values is my purple graph lying above the red graph? And you can clearly see that from here, this is above and this part is above. Only this part, rest of the part, you can see between this point, whatever I'm finding out. Okay, now that is nothing but this point is -1.16 because that was the intersection. So -1.16 was this coordinate, and this coordinate was obviously 7, we know, and this will be a vertical asymptote at x equals to 5. So when I solve this inequality, solve for the answer, in this case, you can see the red part is the only part where the graph is above above the g of x graph. The red line is the g of x line. So g of x f of x has to be above the g of x graph. And that is happening only between negative 5 to negative 1.16, because that's what I find out the intersection. Let me just check once again. If I find G sol intersect, that comes to yes, negative 1.16. So from here to this intersection, it was above. And also, or from minus from 5 until 7. So this inequality holds true between these two x values sets. So what happened is that these two sets are basically in this first set or the second set, the f of x is higher than g of x. And if anybody asks me that, okay, solve where is f of x below g of x? Okay, where f of x is below g of x. Now, if somebody asks, like, f of x is below g of x. Now, in this case, it means where is my red graph above the purple graph? And that is happening only in the range you can see, which I'm highlighting with yellow, is this range, which is basically here. So in the yellow range, you can see from intersection until the vertical asymptote, my red graph is leading compared to the purple graph. So what you do is you just say the answer for this will be, when I write down the answer for this is going to be x between negative 1.16 until 5. So in this range, your g of x is going to be above the f of x graph. So we're going to take more questions of this kind, obviously, in the when I'm doing practice part. But this is, as far as the concept is concerned, this is going to be a very important part for your understanding. So now, one of the last type of question that I would like to touch base upon is where they say number of solution for using a horizontal line. So they say that when I have a function, now for example, f of x is equals to k, it does not have any solution. Now f of x equals to k, it does not have any solution. For what range of k values will this happen? Again, 3-mark question, 2 to 3 mark at least. They will say that using the graph of f of x. Now the function that I had drawn earlier, I'm just gonna delete it because I'm not going to make use of that anymore. So now using this graph that you can see, you have to say that under what condition of k values you will have no solution. Now this is actually, if you look at in a way, one of the toughest question and one of the stupidest question, you can say. Toughest in a way, because if you think in a logical way and don't understand what is f of x equals to k is, now if you anybody, if I ask you what is f of x equals to y equals to k line, you will say that it is a horizontal line cutting y axis at k. This is y equals to k line set of equation. Now what it means is that they're saying that in the question that this f of x equals to k does not have any solution with the function. So this is my function graph, and y equals to k is the other line that you're plotting. So if I draw y equals to k line here, or k line here, or k line here, k line here, you're getting exactly one answer, one solution. But if you see between these values, which I'm highlighting, between these two values, like which is here and here, if I draw a line, something like this, which is, let's say, y equals to negative 1.7 is, I mean, 1.7 is here and 9.5 is here. If I draw a line between those, my function does not exist in between that. So in that case, when you say y, if I take k values between negative, I mean 1.7, I'm assuming this is 1.7 what I got, and 9.5, you will notice that the function is the graph. For example, if I take, let's say, 8, if I solve f of x equals to 8, you will see here that it will just go untouched. It will never meet the y equals to f of x ka graph, because you can see it is never meeting, it's coming below between these two values. So this is something which is called as no solution, or sometimes they'll ask you find out the range of k values where it has got one solution. So if in case where if they would have asked us what k values will give you one solution, in that case, your y would be, or k value will be higher than 9.5, equals to 9.5, or k value lesser than 1.7, lesser than or equals to 1.7. In that case, you'll have one solution. So you have to imagine that y equals to k is a horizontal line, and the function, which is f of x that you take, is the graph that you have been already given. Now let me just take a random graph which I'm showing here. Now let us say this is my function that I have got after plotting the graph, and now this coordinate is, let's say this is 1 comma 6, and this coordinate is, let's say 2 comma negative 4. Now what I want to find out is, let's say y, so this is the f of x graph, and let's say, okay, when you draw f of x equals to k has exactly see three solutions, find out what is that the range, what range of k values you will have, you can take. So when I see that y equals to k once again is a horizontal line, so it's like, okay, if I draw a horizontal line here, it does not meet the graph. If I draw at 3 points, if I draw a horizontal line here, it does not meet. If I draw a line here, yes, it cuts at 3. It cuts at 3 here. Here it will just touch at 2 points. It will cut at 2 points. So in case they're asking for 2 solutions, you take k value as 6. Here again, one solution. So if you look at the 3 solution thing happen between only k values, if I take k values from nothing but -4 to 6, non-inclusive. Because if I take inclusive, if I draw a line here, horizontal line here, it cuts at 2 points. So for 2 solutions, I can take k equals to 6 or k equals to -4. So this is how you use the general logic and the equation set to understand and solve the functions questions. Now this is another interesting part where you need to use the technology for plotting the absolute value function. Obviously, we all know how to do it manually. So let's say just quickly touch base upon this part where, let's say, I have to draw absolute value of this given function. Now here in this part, here, if I cut down and reflect here, this part as it is will be positive. So that part you can just do it directly on GDC. Now let us say if my function is, I'll take a quadratic function or quadratic and logarithmic function, that these two functions are asked. Since like log functions you might be doing later or sooner, it will be interesting to know how to do this. So now what we have is, let's say a function is x squared minus 4x. Let's say this is my function. And what I want to do is I want to draw absolute value of this graph on calculator straight away. So when you're doing that, you can just do option button, numeric button, and absolute. So you'll see, I repeat again, option, numeric, and absolute. So you can get the absolute value function directly on the calculator. And here you can just type out the function x squared minus 4x. So you will be able to see the absolute value graph also on the same. And you can, in that case, you can just delete the first function, and this will be the absolute value graph. And you can find out like minimum, maximum. So minimum is 0, maximum, you can find out there is a turning point at maximum or there. So you can just use the graph for other types of questions. So this is how you do absolute value functions on the graph. And just to quickly touch base upon the logarithmic function, in case if you need to plot, it is option, numeric, not option numeric, option, cal, and log AB. Generally, you log function is already here, but you don't get to the base. So what you do is option, cal, and log AB. So you have, like, for example, let's say I want to draw log x to the base 2. So here we go. So let's say log x to the base 2. You can just get the graph like here. So it's interesting to know all of these things, and in case if you need to use these to solve the functions question. Now what we have is, let's say the major part of the functions in international math is the transformations. if sometimes they ask you questions based on transformations, it might be asked between somewhere between 4 to 6 marks. So let us just quickly touch base upon what does each transformations do, and let's see how we can understand how to apply to the different equations. Okay, so as far as the transformations in international math are concerned, what we get is from these ranges. One is the translation. So translation that you will get most frequently. Then you have your reflections. So reflections across y-axis or x-axis. We've seen like reflections across x-axis more frequently. Then you see the vertical stretches, and horizontal stretches, not very frequent. So, but still, I'm just going to touch base upon that as well. So horizontal stretch as well. So now when you talk about the function being transformed, like obviously the same equation is given different types of like new equations, like same equation getting transformed into new equations to represent the new set of the graphs. Now let us say, for example, if the function is, if there's a function f of x equals to uh, x x squared is the function, or I can just show it with the best ways to show with the trig functions. Let's say sine x graph. Now, for international math, since we don't have radians, I'm just going to keep it in degree mode. So I'll just select the degree mode, and you can see that if your degree mode is on, the similar thing happen on your calculator as well. So you will be able to see like a straight line or something, because you know that minus 360 to 360 and minus 10 and 10, it is a huge difference. So minus 10 to 10, the same sine graph looks like a straight line. But if you enlarge it, like if I just enlarge it like here, you can see until 360, obviously the range is very high. So if I change the range, you can see now basically from, let's say, -2, let's say -2 to +2, let's say something like that. Here, this is, once again, I change to x values. So let's say minus 360 to 360 is the x values. And my range is, I'll just keep it maybe from -2 to +2. So you can see your graph better. Now, this is the one cycle of the sine graph. You can see here to here. That's your general sine graph as you studied in math and I covered in different classes. So I'm not going to touch base upon how do you get this original graph. But now it will be interesting to see how does the translations, transformations, and all work. So now if you have a graph of sine x function, let's say, and a sine x graph, and somebody say, okay, draw the graph of sine x minus 30 degrees. So when you draw sine x minus 30 degree, obviously, let's say f of x, this same things we have done in our additional math as well. Now, in this case, let's say if I attach a slider, I'm just going to quickly touch base upon this. If it is f of x minus a graph, you will be able to see that the graph is moving a units to the right. And if it is f of x plus a, you can see now it is moving to the left. Now, if I change the slider values to, let's say, maybe from -50 to +50 with a step of, let's say, 10, you can see then more frequent movement. So let's say now you can see the graph is moving to the right. It's like sine x minus 30, sine x minus 40, they will move to the right. Sine x plus 30 will move to the left. So any f of x minus a moves to the right, f of x plus a will move to the left. So that's something which is your horizontal translation. Now, if you have been given, let's say, a vertical translation, like vertical translation is basically with the, let's say, plus a. So if I move the graph now, uh, here you will see the graph is moving along the, I'll just keep the steps now to maybe, I'll remove the slider, add a new slider. Now you can see that the graph moves up and down. So if you have to sketch like obviously like something like, let's say, sine x plus 2 or something, it'll move the graph 2 units up. So this is your basic like movement up, movement to the right or left. So as a summary, in case if you want to just remember, f of x minus a units to the right, f of x plus a moves a units to the left, a units to the left, f of x uh, plus a outside, which is like moves up, and f of x minus a moves down. So this is just a basic translation that we discussed. So after this, we have something called as reflections in x-axis. Now, reflections in x-axis is when you obviously make the entire function negative. So if you have a negative of the f of x. Now, for example, if I had to sketch negative of sine x, so that means that the graph is going to just get reflected in the x-axis. So for example, here, it'll be like, if I have the function, something like, okay, negative f of x, you'll notice that the function is just reflected in x-axis. So whenever you have such kind of graphs where you're just making the negative of the entire function, just you reflect in x-axis. That's what is going to be your reflections part. Now, reflection across y-axis is not that frequent. In that case, actually, you make, if when you make x values negative, like for example here, the graph actually is now you've got reflected in y-axis. Now, if I just change the first function from sine x, let's say some quadratic, let's say x square minus 100x or something. So you can see now, actually, I'll just reduce the view window. I'll reload this. I take, let's say, f of x now. F of x is x squared minus 4x. And let's say if I want to do f of minus x graph, you can see it got reflected in y-axis. So whenever you replace, if your function, now for example, if your function is x squared minus 4x, and you're doing the transformation f of minus x on this, it will get reflected, your graph will get reflected across y-axis. It will be minus of x squared minus 4 times minus x. It will become x squared plus 4x. So this graph is the x squared plus 4x graph that you got. So this is nothing but the reflection in y-axis. Now, as far as the vertical stretch and all are concerned, that they are very easy. In vertical stretch, what happens is that just your y values get doubled, tripled, half based on the vertical stretch that we apply. Now, let us say which forms have the vertical stretch. I'll just quickly clean out all this stuff. So when you apply vertical stretch, the function will be like, entire function will be multiplied by like a constant. Now let us say if my function is x squared minus 4x, x squared minus 4x is the function. Let's say this is f of x. Now if I take a f of x, so this is your vertical stretch. Vertical stretch will be now, like for example, let's say if it is 2f of x or something like that. Let's say this is 2f of x, it is going to be a vertical stretch, factor by 2. Now you can see that your x values are still the same, but your y value got double. So in vertical stretch, the graph is actually just like, stretch along y-axis. If I had like same thing with half as a vertical stretch factor, it is going to reduce the y values by half. Like each y value, which is like 2 comma negative 4, now becomes 2 comma negative 2. So this is your basic of the vertical stretch. Now coming back to horizontal stretch, which has not been assessed since very long time, but you can remember that just for additional concept. Now when you have f of, let's say 2x graph, now when I draw f of 2x graph, you'll notice that the graph has been compressed by a factor of half. Now this is just the opposite of what we do in vertical stretch. Like in vertical stretch, if you have half outside, it's like vertical stretch by half, you say. But when you have f of 2x or something, you will notice that the graph is actually getting stretched by a factor of half. This point is at 4 comma 0, and this is going to become at 2 comma 0. Now any point, in this case, you'll notice that the x coordinate remain the same. I mean, the y coordinate remain the same, but x coordinate changes. Like for example, it's like 5 comma 5. This will be 2.5 comma 5, close to 2.5 comma 5. So basically, these are some of the things that you need to remember as far as the transformations are concerned. You can get like, I can just do one more question on like just on the sine functions and all. So we can just be clear about this. So let's say I'm just doing a transformation, quick transformation questions on sine, summarizing everything. So let's say y equals to cos x, maybe sine x we have been doing since long. So cos x, if I want to do vertical stretch, let's say 2 cos x is a vertical stretch factor by 2. Let's say if I have cos of half cos x, vertical stretch by half. If I have, let's say f of, in bracket, f of x minus 1, it moves the graph 1 into the right. It is 1 radian here, but you don't need to worry about. Your answer will be always in degrees in the question. So it moves 1 into the right. If it is f of x plus 1, it moves 1 into the left. If it is cos 2x, you'll notice that the graph has shrunk by a factor of half. If it was cos half x, you'll notice that the graph gets elongated by a factor of 2. So this is just the opposite of what we have been doing in vertical stretch. Now coming to reflection across y-axis, if I have negative y, because it's a symmetric graph, it will be the same graph. But if I have a negative f of x here, you will notice that the graph gets reflected in the x-axis.